Welcome back. So now let us discuss more about coordination compound. For us to understand coordination compound in details, we have to first understand Werner's theory. But before then, I have told you that inside this coordination sphere, we have two types of what? Of involving ions. Number one, or involving atoms or molecules, we have central atom, which is central metal atom, right? It is usually a metal and then a ligand. So this ligand, we can have two different ligands inside the coordination sphere. They are all ligands. Whatever you see inside this coordination sphere, they are all ligands, with the exception of what? The central atom, and then counter ion is usually outside, whether a positive ion or a negative, whether you see it from this side or on this side, from left side or from right side, they are all counter ions as long as they are outside the coordination sphere. I hope you understand this. So also you can see this ligand, it has its own coordination number, and also this one has its own coordination number. So let us move. Now Werner theory. Werner, he was the first scientist to study coordination compound successfully. And now what he did, he reacted cobalt chloride and ammonia, and then he get COCl3.6NH3. Then now he further reacted this compound that he found, he reacted it with silver nitrate, and then he get 3 moles of silver chloride. I hope you understand this. So then he assumed that the nitrogen is directly bonded to the cobalt, which is the central metal atom, and then chlorine is indirectly bonded to the cobalt. So then he drew this sphere, the one that is directly bonded to the cobalt, then he put them inside the coordination sphere, and then the one which is indirectly bonded to the cobalt, the central metal ion, then he put it outside, which is chlorine, right? So this is counter ion, and the one that is inside is what? Is ligand. And then the other one, which is also inside the coordination pair, is the central metal ion. So now let us see how this structure is being formed. So before learning how to draw the Werner structure, the first thing to do is to kindly learn about the Werner's postulate. So Werner concluded that every metal atom of coordinate compound has two types of valencies. Number one, primary valency, and number two, secondary valency. As for primary valency, it is satisfied by negative ion. Example, chlorine is a negative ion, right? Which has satisfied the primary valency of cobalt in this structure. I hope you understand this. We are going to explain this in details. And then secondly, it represents oxidation state of the central metal atom, and then it is also denoted by dots. It is denoted by dots when we are going to draw the structure. So any primary valency, that is, you are going to see a dot which is the representative of primary valency, and then it is ionizable in aqueous solution, that is, it can go into reaction, it can react further when something is added to that coordinate compound. For instance, in this equation we can see once this silver nitrate is added to this compound, right, this chlorine, which has satisfied the primary valency, it goes into reaction and then form a white precipitate with silver nitrate. Do you understand this? Yes. All right. Then let us go and see the secondary valency. I hope you are jotting all these points. The secondary valency, which opposes the primary valency, is satisfied by ion or molecule. Example, ammonia in the previous structure is a neutral molecule, right? It satisfies the secondary valency of cobalt. We are going to see this secondary valency when we draw the structure. And also it represents coordination number. That's another. This secondary valency represents coordination number. As we see, we say this 6 right here is coordination number. Do you understand this? We are going to see it in the structure. And then uh, it's denoted by lines. It, as opposed to the primary is by dot, right? So secondary is denoted by lines. We are going to see this, don't worry. And then non-ionizable in aqueous solution. It is not ionizable in aqueous solution. For instance, ammonia is directly bonded to cobalt. It is not ionized. For instance, in this reaction, as we see, the only entity which ionizes is chlorine, right? While the ammonia here is inside the coordination sphere, which means it is directly bonded to the cobalt, so it is not ionized. We are going to see this once we are explaining how to draw the structure of Werner. Now let us continue. So understood secondary and primary valency. Now let us see how to calculate these primary and secondary valencies. So before calculation, let us see the structure. This is a cobalt, right? Remember, this is the structure, right, that we found. We are going to also learn how to name this structure. So we see the central metal atom is cobalt, right? So it is in the center as we see. And then we say that the chlorine is not directly bonded to the what? To the cobalt. It's that it is a primary valency, right? So as we see, it is represented by dots. Do you see? Then we say for secondary valency, ammonia is what? A secondary. You can see we have 6 lines. That's why we say it represents coordination number, right? So we have 6 molecules of ammonia, which donate 6 lone pairs of electrons to the cobalt, which makes the secondary valency Sb equals what? 6. Do you understand this? So this is the Werner structure. This is how you draw Werner structure. Sorry, not Werner structure. This is based on primary and secondary valencies. We are going to learn how to draw the Werner structure in this form. Alright, let us calculate primary and secondary valencies of a central metal atom.